All right. Hello, everyone. My name is Zach. I am a AI and machine learning product specialist here at Neo4j, and I'd like to take some time to talk to you about building intelligent AI systems and some of the new cool tools that we have coming out to help you do that. So the way that I've organized this is I'm going to talk about some of the new things that are coming out. This is going to be Aura agents and MCP server for Neo4j. So I'll mention those really quickly. But then I actually wanted to get into sort of why graphs for AI in general and sort of how graph and GraphRag help with context engineering. I'll show you some stuff through our new MCP server for Neo4j. I'll take a deeper walkthrough through Aura Agents, which is a really cool new platform. And then I'll go over some follow-up resources for learning and just getting more hands-on with the product and different resources we have here at Neo4j. So what's new? So there's two cool things that recently came out. First, I want to talk about the MCP server for Neo4j. So for those of you that have followed us at Neo4j for a while, you know that we have model context protocol servers that have been available through labs. And MCP is just a protocol that exposes a bunch of tools, right? It's a standard to different agents and AI systems. And we can expose Neo4j to that. And recently, what we've done is we've taken that into our core engineering, and we now have an officially supported MCP server that's in beta. It's available today. It's been written in Go. It's open source right now. You can get it and manage it yourself and then connect it to your Neo4j data. And then the next thing that is also really cool is our Aura agents that is in early access right now. So it's in an early access program or EAP. And what that is basically an end-to-end platform that lets you build, test, and deploy agents in a matter of minutes. It's low code, no code. It is grounded, by default inside of your knowledge graphs, basically one of your AuraDB instances. And it's going to go GA later this year. So I'll show you both of these things live in a demo. But before I do that, I just want to talk about why graphs for AI. And basically, what graphs help you do is manage context to boost accuracy, improve explainability, and future-proof your AI systems. And I have a little diagram here that I can show you, which kind of runs through the general GraphRag architecture that we often see. And a lot of these components will look familiar, right? You'll have a UI that exposes enterprise search or some sort of knowledge assistant. You'll have your AI provider, whether that be OpenAI or Bedrock or Vertex AI from Google or one of these that will give you language models and such. And your agent will have tools that it can grab with MCP or whatever else. And you have your data here, which can be unstructured or structured data, unstructured coming from documents, and then structured data coming from things like relational tables or CSV files or what have you. And so when you put a knowledge graph in the middle here, basically what you're able to do is expose a lot of context around how your data is structured that allows an agent to sequence things in either a multi-hop behavior or construct queries or graph patterns that makes it basically optimal to fit inside of the context window. And I'll show you what that looks like a little bit here through a demo. Basically, the demo that I'm going to show you, we'll take an example from an employee and talent agent. So I've prepared some dummy data, some resume data, and the employee agent will be responsible for assisting with skills analysis, talent search, and some stuff with collaboration and teams review. So if I go ahead and look at the source data here, we have this data right now contained inside of a bunch of resumes. So I have about 30 resumes here. That just sort of, list things in plain text. And what comes up really quickly is if we just take these resume texts and parse them and put a vector index on them and just search them with vectors, we'll find very quickly that we don't really get what we need. So I have a notebook here that's demonstrated that, where basically even simple questions, if I just ask a question like how many Python developers I have, right, in my set of people, all that it can really do is search for Python developer from the text, right, using something like semantic search. And it will tell me that I have 5 Python developers because it will hit the limit on the number of documents it could take. So we'll really only get 5 resumes back. So there's ways that you can work with metadata, right, to kind of document metadata to work around that and maybe get a better answer. but not all questions are that easy. For example, if I asked here for something like summarize my technical talent and skills distribution, again, all the agent can really do with a vector search tool is plug these generic search terms like technical skills and programming languages. And so while it may get a response back, this response is likely not going to be accurate. It's not going to be complete because it's just the 5 top resumes that happen to match that generic search criteria the best. And so basically what ends up happening is, regardless of how sophisticated a language model or how advanced a platform or framework, agent building framework that we try to throw against this, we're not going to be able to scale with just vector search. We're going to run into problems. And the core problem is really that we're not managing and organizing our context and our data in a way that an LLM can pull efficiently. And so we can fix this problem with a knowledge graph, basically to organize and manage the data so that we can get that context and pull the right information in. So what I'll show you here, if I go over to Neo4j, get rid of some of the queries that I was running earlier. And let me make this a little bit bigger for you so you can see. So I've gone ahead and loaded this data, and I'll talk about that in a second. But I wanted to talk to you a little bit about the schema that we're going to make from those resumes. So here's the schema. And we can start simple with these schemas. We're basically going to take our documents and extract entities into this schema. And you don't have to migrate all of your data right away, by the way, if you're starting outside of a graph database. You can start small with a very simple schema like this and then build on it later. So there's no need to migrate everything right away. But basically, all I'm going to say is I'm going to have person nodes, and those people are going to know different skills, which is another node, and knows is a relationship. And then those people are also going to be able to accomplish various types of projects or things. So publish, build, win, manage, etc. And those things can exist inside of different work domains and be of different work types. And all of the code that I use for this, I'll link to the repository later in the deck. I'll give you a QR code for it, so you'll be able to get to all of it. But we basically perform entity extraction and put this information inside of a graph database. And what that looks like once it's done is kind of like this. So this is just a sample of the data, but you see here we'll have our people, which will have text from the resume, as well as an embedding for vector search and some other metadata. Those people will have skills, as you see here, like leadership. We have project management. We have SQL here, team management, all of these things that connect them together, connect between multiple people. And then we also have these projects that people work on, and those are connected by the domains. So for example, DevOps and cloud, as well as different work types. So infrastructure, system, project, etc., connecting all this data together. And once we have data in this format, we can do something called pattern matching using Cypher, which is our query language, to pull that data back in a logical way. So for example, I can do a pattern like this in Cypher, which is basically saying, hey, find people who have built different things or projects inside of different domains. And I just limit it to the first 20 here, just so we can visualize it. And you'll see here, we'll get our people, build, right, different projects. And those projects are in different domains. You can see there's a couple different examples here. And effectively, we can make this logic available to any AI system through our MCP server for Neo4j, or really any MCP tooling, right? And that's where we're able to make all of this context available and boost our explainability and our accuracy. So to demonstrate that, I'll show you what that looks like inside of Claude. Slide over this way. And basically with Claude, I've taken our MCP server for Neo4j. I've called it Employee Cypher Tools, and I've configured it to get the schema and run Cypher here. So basically the two types of tools that are available, right, is to get the schema of the graph and then to execute those Cypher queries, those pattern matching capabilities. And so now what happens is if I want to ask a question, for example, here, let me take my Python developer headcount question, find it. Over here. And if I go ahead and ask that question, what will happen is it will think about this for a little bit. And then the first thing it should do is get the graph schema, which we see here. So you can see the text, which is basically that schema that I was showing before when I first went into the console. And then now it's going to look for the number of employees. You can see the pattern matching here for the number of employees. And then you'll see it comes back. It tells me I have 28 employees that know Python, which for this data set is the correct answer. I went ahead and validated that before this. And then you see that it will actually explain its logic, and it can explain it on a very technical level. This is exactly how I queried the data. It's just in natural language explaining the query that it used. And then it will list, all the developers, and then potentially other insights that it has down here. And what gets really interesting is when you start asking those more complicated questions, like this one that we had before about summarizing the technical talent and skills distribution, it can actually start chaining these commands together. So it's not just going to write one cipher query, but just because of the way a natural language has kind of a chain of thought reasoning, the language model has chain of thought reasoning in this case. It can sort of think about having multiple of these queries fire off at once. So you'll see here, I'll look for persons knowing skills, and then it will look for people, accomplishing different things here, going on and on sort of down the list, looking at different work types. And then it's going to go ahead and create a graphic, and this might take a while, but it's basically going to make an interactive dashboard for us. So again, right, we were able to accomplish all of this simply by having this MCP tooling available through sort of our official MCP for Neo4j product offering, and then having all of that context in the graph with a schema and the cipher pattern matching capability. So we'll give it a second here to come back. This might just take a minute for it to spit out all the code it needs for the visualization. And here we go. So we get our visual back, right, with the total number of employees, key insights, top technical skills at the company, department distributions. We can look at the project domains that we have, the different work types, and it should give me a written summary here, again, explaining all the retrieval logic. So we have this explainability component now because everything's sort of symbolically represented in this graph. And we basically get everything that we need, right, to start answering these questions much more accurately. So, that is really cool just by itself. Again, using that MCP for Neo4j server. And now what I want to talk about is how we can build on this even further when we think about Aura agents. So I'm going to talk about the next product in our lineup here. And Aura agents, so I had to sum it up in one sentence. What this allows you to do is build intelligent agents that are grounded in your Aura DB knowledge graphs with an end-to-end agent creation platform. So basically, from building to testing to deploying everything, you can do all of that in minutes inside of a low-code, no-code interface that we'll go over in a second. And it sort of seamlessly integrates to the retrieval and reasoning logic that we were just going over on your data. And because we handle all the infrastructure for you, everything from the agent to the embedding calls and all this sort of stuff, it greatly simplifies your AI stack and your AI ops. And specifically, the key components, right, is really being able to create the agent through that low-code, no-code builder, having different retrieval tools, which we'll go over, which is cipher templates, vector search, and text to cipher, having a playground to test the agent, and then being able to deploy the agent and access it through an API. And right now, the agent deployment is available through a REST API. There's an Aura API endpoint that we have. So Aura API is something that exists for just managing your Aura instances inside of the cloud, which is our fully managed cloud offering for Neo4j databases. And MCP support for that is going to come soon, although you can wrap this very easily inside of an MCP server, and I'll show you how to do that here in the next few minutes or so. So, oops, not sure what happened there. Let's see. All right, so we'll move on to our demo now. If I go back, I'll open up this window. So basically what I'll do is you'll see an agent that's already created here, but I'll go to my agents tab and I'll just start creating an agent. So there's this, if you have the early access, there's this agent preview here, and I can go ahead and select create, and I can just start building this agent inside of Aura. So I can say I want maybe an employee agent. We'll say employee agent 3, so that it deconflicts with the other ones that I have. I've done this a couple times. I have a pre-prepared one as well. Aura agent 3, and we'll call it employee agent here. And then I can go ahead and add a description, conduct skills and talent search and such. And then I can go ahead and add prompt instructions. So if you're familiar with building agents, you'll know that there's this thing called a system prompt, right? That just tells it basically general instructions on how to behave. So all the stuff in here is just telling it kind of what's in the knowledge graph and then how to use some of the tools that it has. I can go ahead and select a target instance. We'll go ahead and use the same graph that we were looking at earlier, which is this employee graph. I'm going to go ahead and select external. Internal will basically mean that I can test it through this UI continuously. When I say external, it just makes it available as an endpoint, so then I can use it in downstream systems. And then I can go ahead and start adding tools. I need to add at least one tool to try this out. And I can start with something simple. So for example, similarity search, which I think a lot of people are already familiar with. And I can just say, hey, I want to create a resume search tool, and I am going to give it a description. For example, like this: search resumes using semantic similarity to identify and retrieve potentially relevant info and associated metadata on the person. I have a warning not to use this for counting and aggregation. This is just for the language model. When it sees this, it will basically use this information to select the tool and then figure out how to appropriately use the tool afterward. And the embedding provider, in this case, we used OpenAI with our data and text embedding ADA. So these are, sort of free of charge. These get called at query time to go ahead and search the database with vector search. And then the index name, I believe for this one, is text embeddings. And we'll go ahead and do top K of 5, just as an example. The language model that we use, by the way, here is Gemini 2.5 Flash. And that's offered out of the box. So it's not like you have to have your own model provider that you configure with this. We have a model provider in here. And that's just the model that's used. So you don't have to worry about that side of the infrastructure. And now that I have that tool, right, I can ask a question. Like I can say, hey, this is sort of the playground testing UI. I can ask which resumes speak to strong AI skills. And when I do that, it will think for a while. And then eventually it should come back with a response, hopefully using the one tool that I have here. And you'll see it says based on the resume search, and then it will bring back an explanation and, a set of people here. And it brought back 5 people. And you'll see here, there's an explanation, right? When it says thinking, where you can see the reasoning. So I see the reasoning. It says, hey, it has to find resumes. It knew to use, well, it only had one tool, right? But it knew in this case to use the resume search tool. Here's the input it had, and then you can see the output, and then any other logic or reasoning that it did after that. So all of that's exposed, and it's exposed to the API as well. So we maintain that explainability going all the way to the end user application. And I can add other tools here too, right? So I can go ahead and, for example, add a tool around text to cipher. Text to cipher is, we actually used a fine-tuned version of Gemini for this that's specifically tuned to generate cipher, again, our query language, based on natural language responses. And for this one, I can add extra description to kind of guide it on, hey, when should I use this tool? In this case, I'll give it a pretty generic one to just answer free-form questions. But I could sort of direct the agent here to only use this in certain scenarios or as a fallback, because these things are sort of dynamic. They have a stochastic element to them. But anyway, I'm just going to use a very generic prompt here to just, hey, for free-form questions and for aggregations, basically. And then once I save that, you'll see it'll show up here. Both these tools will. And then I can ask a question like, which, a good aggregation question here might be, hey, which people have worked on the most things or projects? And then it'll think for a while, and then hopefully, right, it will be able to figure out that it needs to select this choreograph tool to perform that aggregation. You'll see here that it went ahead and did some form of aggregation here to pull people back. So I suspect that if we look here, you'll see it used the right tool. It basically gave some input to this tool to then generate this pattern here to match people who have, all these relationship types: one, built, led, managed, just like we saw in the schema, basically worked on things, and then go ahead and count that and return by the names. And you'll see here, this is the output that it got. So very simple. Now, what gets really exciting about this as well is that we can start to add here what are called cipher templates. And because I'm going to fat thumb that when I do this live, I've prepared another agent where I've filled that in already. But an interesting scenario that we can look at for this would be something like, I'm going to plug in some parameters. These are just going to save some IDs. But basically, figure out how are people similar, right? So if I wanted to, for example, in the context of an employee or HR scenario, find backfills for someone, for example, I can say, okay, well, I want to identify a pattern where if I have two people, find all the ways that they're similar according to my graph. And the great thing about Cypher and graphs is that I can have these flexible patterns where I say, hey, just traverse over 0 to 1, basically 1 to 4 hops effectively, without going over another person, and just count like all of the different ways that these people are similar. And so you can see with these two people, basically, I can go ahead and see that I get, two people, and then I get the skills that are similar here, and then I get projects that they've worked on inside of common domains and common work types. And that can be very useful for when you need subject matter expertise inside of the tool. So rather than just relying on vector search, which could be opaque, here I've actually broken this down inside of a graph. I can score this in various ways. I can count like the number of hops and relationships, which I do inside of this tooling that I'll show you here in just a second. And that'll allow me to return, pretty sophisticated responses that are well validated, right? And this logic is flexible so that if I change or adjusted my data model, I have a flexible schema and a query language that would accommodate new types of nodes, right, being added in between them. So there's nothing restricting them to just work types or just skills or whatnot. So basically, go ahead and save this guy and then exit out. I have my original employee agent, and I will go ahead and press edit just so you can see where I've filled in the find similar persons, where I have that query pattern that does the scoring. It basically just counts, the number of paths between people. And then I have my find similarities between people here, which is similar to the one I was just showing you, and it serializes the information. So it basically will, in text, kind of explain to the agent how exactly two people are similar according to the graph. And because I have this public endpoint available, if I go into our blog here that we recently wrote, there's an explanation, if I go down towards the bottom, of basically how to call that endpoint. And as well, there's this step that will explain through model context protocol here, basically how you can create a server that will call that endpoint, an MCP server that will call that endpoint, which is exactly what I did. And what that allowed me to do is, if I go back to my Claude window here, I've gone ahead and created this tool, which I'll turn on now. And this will call that Aura agent endpoint. So I'm making it available to Claude now. We now have a multi-agent system where I'm calling this upstream graph agent. And the only one thing that I did here is inside of my settings, just for transparency here, there's this profile setting inside of Claude, which is like Claude's system prompt almost, or information that I guess gets, added to its system prompt, so to speak, where I can say, hey, prioritize using expert agents where you can. And then I also added some extra stuff in here to help it surface the retrieval logic so we could see that earlier. But I added to prioritize using expert agents where they're available. And I've named my MCP server, an expert agent tool when I configured it with Claude. So basically, let's go back to our original window here. Give it some time to load. And yes, this is where we were before. This was our visual. So basically, now I can go ahead and ask a similarity question, like who is most similar to Lucas Martinez and why. He exists inside of our database. And it will hopefully think about this, and then it will use our expert agent here to pull that information back. In this case, it's going to go for running Cypher. Sometimes that happens with agents. Now it's going to call the agent. So it's interesting, right? Let's see what it did. It looked like it called to get all the information from him in the graph, but then it realized, oh, I should probably call the Aura agent because it was sort of in my prompts to go ahead and do that. It's backwards, but it's working. So let's see what it comes up with here. It's going to go for some more details, but we can look at what the Aura agent call looked like. So it asked the question here, and then you can see that the Aura agent was calling those find similar people, and then find similarities between people. So it called those same Cypher templates that we wanted it to call there. And you can see it sort of scored everyone according to the graph logic that we had. It explains its retrieval logic, and then it basically says, here's the most similar person that in theory you could backfill this person with. And it explains the skills, similar work profiles. We saw the system and product stuff in the last query. So very interesting kind of how you can have that all deployed right through that Aura agent. You can use the Aura agent by itself, or like I showed here, you can use it inside of a multi-agent system. All righty, so let's go ahead and wrap up because I think we're very, very, very close to time here. So in summary, right, with Aura agents, we have this low no-code agent creation. We saw the admin UI that you could set up, how you can test and deploy it. That deployment has, it's all authenticated through the Aura API, so it's secure. There's a client secret and token and all that sort of stuff. We saw the different types of graph data retrieval tools between the Cypher templates, the similarity search, and the text to Cypher. The text embeddings that were supported. We have OpenAI and Google Gemini as well. There's more to come later. the testing UI, and then the endpoint that we saw that got shipped, and we were able to call through our MCP server. And this will be available in Aura free, professional, and business critical tiers. So some resources for you to check out. We have a new webpage, which I'm biased because I helped make it, but I think it's great. It goes over a lot of very general sort of resources and kind of explains some of the context stuff. It has links to Graph Academy and a bunch of other places where you can go and learn more, get different blogs and stuff like that. For Aura Agent, specifically on October 25th, we'll have a virtual workshop in Road to Node. So that'll be a great one to check out if you want like a much longer period of time to really sit through and learn how to build these agents and get more in depth with them. Tutorials in GitHub are here, including the example that I just went over, and a couple other examples as well. And then there's a technical blog that goes over a lot of the stuff that I just went over, but with a different contracts agent example. For the MCP server, you can get that through GitHub. There's directions there on how to configure it. It's all written in Go. I think there's a binary that you can just get and just you can use it automatically for whatever your operating system is. I have an example in GitHub. So this will link to all the code that I use for the entity extraction and all that stuff in the graph that I was showing you. And then, of course, in Neo4j Labs, we actually have much more different types of capabilities. So we have like data modeling and even like graph data science stuff, graph analytics. So there's other MCP servers that are in labs that are more experimental, which we haven't taken into core product yet. So if you wanted to explore that, that's very interesting as well. So that is all I have for you today. Hopefully this was informative. And yeah, I'm excited. Hopefully you're excited too. Thank you, everyone. Have a great day.